So we are live. Thanks a lot for waiting. Let's get started. So I am Nishant. I am here with Lalit and Akash, and we'll be talking to you about CodeJam Kickstart. So let me give a brief summary of what's going to come. We'll be first talking about what exactly is CodeJam Kickstart. Then we'll follow it up with some of the previous questions that have been asked in this contest, and we'll try to teach you how you can approach those problems and solve them. We'll follow it up with a couple of tips and tricks, and finally we'll get to the questions. Before we get started, let me do a quick round of introduction. So, hi, I am Nishant Redkar. I've been working with Google for the past 10 years. I've been active with the competitive programming community. I participate in a couple of contests every year. And I'm also actively involved in setting problems for Kickstart and other contests hosted by Google. I have with me Lalit.
Yeah, hi everyone. I work on Tej at Google, and I've also been very involved with creating problems for CodeJam and Kickstart and so on.
And we have Akash.
Yeah, hello. So I'm being part of Google for more than 3 years now, and I'm also actively involved in problem setting for CodeJam, for Epic tests, and now Kickstart.
We also have with us a couple of chat moderators. I believe you would have already interacted with them. We have Deepak and Asim on chat. So let's get started. What is Kickstart? Kickstart is a CodeJam competition for students. You may already be aware of the CodeJam platform, which is used by Google for conducting several online contests. One of them being the Google CodeJam, which happens once every year. That is for all students and professionals alike. Kickstart is just like the other contest. It's an online contest, programming contest, which happens throughout the years. Throughout the year, it is not a single round, but it has multiple rounds. This year, we have completed 6 rounds, and the 7th one is going to happen soon. Each contest has multiple algorithmic puzzles, and each one of them is designed by Google engineers. So why participate? What is it for you? First and foremost, you will get a glimpse into the programming skills that are needed for a technical career at Google. We as Googlers are expected to be good at algorithms and data structures. We ask similar problems in this contest, in our interviews, and so on. Secondly, you will get acquainted with the CodeJam competition arena. As I mentioned, this is a platform used by Google to conduct several contests. And another reason would be you may get, if you ace in the contest, if you do well, if you are in the top few, you may get contacted by a Google recruiter for a career opening at Google. And most importantly, according to me, is that you will have fun. You will compete with your friends and test your coding skills, discuss the problems after that. All in all, have a lot of fun. So when is Kickstart? As I already mentioned, we have already completed 6 rounds of Kickstart. The 7th one is happening on 22nd October. How many of you know what was Kickstart previously called? You may have guessed it. It was called the APAC contest. We changed the name to Kickstart because we expanded it beyond the Asia Pacific. It is also conducted in the United States, in Australia, and so on. So go ahead. You still have the 7th round. Go and register. We have the link for you there. So participating is one thing. Practicing and doing well is also quite important. So how do you prepare? In this contest, we test your fundamental data structures and algorithms. You should be well versed with stacks, queues, lists, and other such data structures, and the basic algorithms, which would include the sorting algorithms and a few more. You should be well versed with data structures like graphs, trees, hash tables, why are they used, what's the time complexity of insertion, deletion, all those things, the basics of data structures. You can code in any language of your choice. You can have a preference of coding in Python. Feel free to do so. You can code in shell script, you can code in Ruby, anything that you please. And finally, you should be good at catching the bugs that you introduce in your code. You should be able to test your code, debug it well, and submit a correct solution which works on all edge cases. Then let's take a look at the CodeJam platform. How do you actually submit a solution? The first step is read the problem, come up with a solution, an algorithm, and implement the code for it. Then you will have two input files present on the page. One would be the small input set, the other one would be the large input set. Go ahead, download the small input set and run it with your solution. This will generate an output file. Make sure you generate an output file from this. That there is a time limit of 4 minutes for the small input. You generate your solution in that time, submit your output and the source code on the site. If it passes, repeat this step for the large data set. If it fails, go ahead, debug your code, fix whatever edge cases there might be that you might have missed out, and then try again for the small input. Once it passes, go for the large data set. So now let's move on to the questions. But before that, for this particular talk, we have fixed a theme. We have picked dynamic programming as the theme of the problems that we have picked. Not all the problems are dynamic programming, but it is basically the theme of the contest. So theme of the talk, it is similar to the code lab that we had shared previously. So let's move on to the problems. I'll hand it over to Lalit to talk about the first problem.
So this is a problem from Kickstart round B this year we had, and this is one of the easiest problems from the contest. So you can follow the link that is present in the slide. So in very simple terms, this problem says that you're given an array of n positive integers, and then the problem setter wants you to consider all the non-empty subsets of this array. So, and then for each of the subset, you find the value, you find the difference between maximum and the minimum value in the subset and add it to your answer. And eventually you have to output this answer modulo a prime, because there are a huge number of subsets and this value could outgrow the maximum value that can be represented in a 64-bit integer. So if you consider the example that has been specified in the slide, we have an array consisting of 3 integers, and then we have listed down all the subsets of this array. For each of the subset, we consider the difference between maximum value and the minimum value, and then we output it. Now, what a very intuitive approach to any problem is that you should first of all come up with a working solution, a correct and working solution. Don't worry too much about the complexity and the efficiency. So in this problem, a very intuitive solution could be generating all subsets, which would work for the small input. So as Kickstart engineers, we make sure that even if you're not able to come up with a very efficient algorithm, there are some points that you can gather on the small input. So how to generate all the subsets? This is a very standard bitwise trick where you can represent each of the subset by an integer between 0 and 2 power n minus 1 inclusive in base 2. So here's the pseudocode for generating all the subsets. So we iterate over I from 0 to 2 power n minus 1. And for each integer I, if jth bit of I is set in base 2, we say that the jth element belongs to the subset. So using some bitwise tricks, we generate a subset and then we work on this subset. So in this case, the work we would be doing on a subset is adding the difference between maximum and minimum value to a global counter. Now this works really well for the small input, but for large input, the value of n is up to 10 power 4, and generating all subsets for such a huge array is not possible with the memory and time limit constraints that we have. Now comes the part of making some observations. So the first observation that we should make is, what does a subset contribute to the answer? What are the elements that make a difference in our answer? So for a subset, we are considering only the smallest and the largest values in it. So in a subset, the smallest value contributes minus v to the answer, and the largest value v prime contributes plus v prime to the answer. Moving ahead. So imagine this. Let's say we have sorted the array and we define f of I as number of subsets which consists of ai as the minimum value. Since there are n minus I minus 1 values greater than ai, consider that we have sorted the array, we can choose any subset of these n minus I minus 1 values and add ai to that subset. This will generate all the subsets which have ai as the minimum value. So we can say that f of I is 2 power n minus I minus 1 because there are 2 power k possible subsets of an array of size k. Similarly, we define g of I as number of subsets in which ai is the maximum value. And by similar logic, we can arrive at a conclusion that g of I is equal to 2 power I. Now, we approach this problem by adding the contribution of each value to the answer. So we want to find out what is the contribution of ai to the answer. When it is the minimum value in the subset, which is f of I such subsets, it contributes minus a of I. So in that case, its contribution is minus of f of I into ai. And when it is the maximum value, it contributes g of I into a of I. Now, for each of the ai, we can add their contribution to the answer. And the only thing that we are left is how to calculate f of I and g of I efficiently. So f of I is basically 2 power n minus I minus 1, which is a power of 2. So a great hint in this case is that we are going to need 2 power I for all I between 0 to n. And that can be calculated easily using pre-computation. So if you have calculated 2 power I minus 1, you can multiply it with 2 to get 2 power I. Now, what are the common pitfalls that someone can fall into in solving this problem? So two major things to solve such a problem is to come up with an algorithm first and then implementing it. So you might miss some observations and go towards a cumbersome number theoretical approach, which is certainly correct, but might take up a lot of your time, and there might be a lot of implementation bugs if it's a complicated approach. Even for the simple approach, it's very easy to make some implementation mistakes in which you have integer overflow. Let's say you're not covering all the corner cases. So for languages like Python, which have big num libraries, these kind of mistake would not occur. But contestants who are working with languages like Java and C++ should take care of these things.
So before we move on to the next question, we have a question from Tamanna. She says, please explain the pseudocode again. Let's go back to the pseudocode.
Yeah. So as we said that every subset can be represented by an integer between 0 to 2 power n minus 1. And I've used some of the bitwise operators. So 1 less than n basically says bitwise left shift 1 by n times, which basically generates 2 power n. Now for each I, we are going to do some computation to generate a subset using this value I. What we have built a convention is that if the jth bit of I in base 2 is set, basically it's a value 1, then nth value, then jth value belongs to the subset. So I iterate over j from 0 to n minus 1, and then for each j, I check whether the jth bit in I is set or not. That I'm doing in line number 7. I raise 1 to, so I basically take bitwise OR of I and 2 power j. And as you should observe that 2 power j is basically, 2 power j has the jth bit set, that's it, and all other bits are 0. And if you take bitwise OR with I, you will get a positive value if ith bit, I also has the jth bit set. So if that is the case, then we add it to our subset. Hope that explains.
Okay, let's move on to the next problem.
Yeah, finally we are on to our theme, which is dynamic programming. And dynamic programming is one of the favorite topic of problem setters in various contests like Code Jam and Kickstart. And it's a very interesting philosophy as well. So in this problem, Wheatley is in a party where there are infinite cakes, and each cake is a square shape. So we have infinite supply of cakes with side 1, 2, 3, and so on. Now Wheatley aims to eat cakes such that the total area of cakes he is gonna eat is n. N is given to you in the input. And Wheatley wants to do such a thing by eating minimum number of cakes, minimum number of distinct cakes basically. So for example, let's say Wheatley wants to eat total area of size 4. So either he can eat 4 cakes, each of side 1, in which case the area of each cake is 1, or he can just eat a single cake of side 2, which is area 4. And this is a better solution, in which case he just has to eat 1 cake. Now, like any other dynamic programming problem, you should observe that n is expressed as sum of smaller numbers. So we should try to break down the problem into smaller subproblems. So let's say I define f of n as the solution for n. So f of n is defined as the minimum number of squares in which it can be expressed as a sum of. Now let's assume that Wheatley is going to eat a cake of size k. Note that there are various possible values of k that can be chosen. If he has chosen k, then his job, what he is left with, is he has to eat an area of n minus k square. And this forms the basis for our dynamic programming solution. So we say that to find f of n, you iterate over different values of k in line number 4, as you can observe, and then you calculate the answer for the remaining part. So in line number 6, we are saying that this 1 cake we have already eaten, which is of side k, and now we are left with a job to eat total area of size n minus k square. We do this for all possible k's and take the minimum of them and return the answer. Can you observe how many different values can k take? Note that there is a condition in line number 5 which says when we stop. So we stop when k square exceeds n, because Wheatley doesn't have a capacity of more than n. There is no reason of considering k as one of the possible constituents of the answer. And the final step in coming up with a problem is to calculate how efficient that solution is. So as you might remember, in the code lab, we had mentioned a technique of calculating the complexity, which basically says the total complexity is the total number of different states in your dynamic programming solution. So in this case, which is order of n, because f of I where I can go from 0 to n. And there is a certain cost of transition, which is basically the different values of k that we are considering for a given n. Now for a given n, we are considering at most root n values of k. And then due to this, we can say that the complexity of our solution is n into square root of n. There is an alternative solution using Lagrange's theorem, which says that every positive number can be expressed as a sum of at most 4 different perfect squares. So our answer can never exceed 4 by this theorem. I won't go into the details of the proof, but assuming this is true, our only job is to express n as sum of k different squares where k doesn't exceed 4. So we just have to iterate over possible different values of first k minus 1 squares. So let's say they are a1, a2, a of k minus 1. Then we can make an assertion whether a certain solution is valid by checking whether n minus summation ai is a perfect square or not. And again, this works in n root n, because ai can have at most, the maximum value of ai can be root n, and k doesn't exceed 3.
Okay, so before moving on to the next problem, let's take one question by Sujit. He says, can you guarantee that if I master object-oriented programming course, will I be able to solve the problems? The only thing that I can say is, if you practice solving these problems, then you'll be able to solve these problems. I don't see that mastering any theory, may it be object-oriented programming, may it be dynamic programming, may it be any other theory in algorithms, you will be able to solve this problem. The only way is by practicing more and more problems. One of the hardest part of solving a problem is the first part, where you analytically come up with some interesting observations. You might have noticed in the first two problems that we have mentioned some key observations. Now, those are not covered in the theory of computer science, or they're not covered in the object-oriented programming course. Those will come naturally only when you have solved a lot of problems, similar problems, and that is when you would be able to solve a similar problem like this. Okay, so yes, so before moving, okay, so for the next problem, I will invite Akash, who will talk about an interesting problem.
Thank you, Lalit and Nishant, for explaining so well. Yeah, so this is a little tricky one. So first I will try to explain the problem, and then I will help you in building the solution. What steps you can take in coming up with a dynamic programming solution. This might look little tricky, as of course it's one of the hardest problems in that particular round. It's from round B, problem C, named as Christmas tree. So the problem goes as follows. You are asked to find the maximum number of cells in a Christmas tree of given height k. Now the Christmas tree is defined as, of height k is defined as that such that it contains k different triangles on top of each other. Now what is a triangle? A triangle in this particular problem is an isosceles triangle which contains the symbol hashes in the following manner that we shown in this particular image. So if you see here, we shown two different triangles in these images. The first one is of height 2. So this triangle height is different from height of the Christmas tree itself. So you can see that the triangle in the figure second, the larger one is of height 3. So similarly, we have a triangle of height 1 which contains only a single hash character. So in going forward, we will define a valid triangle that will only contain the hashes characters in triangle figure. Right. So now in this figure, we are showing a Christmas tree. So the tree is defined as if there are multiple triangles connected to each other, it can be only one triangle itself, that is also a tree. So in this particular case, in this figure, we are showing that the two triangles from the previous slide are connected to each other. So this forms a tree. So now you can see that from this particular figure, it's not necessarily that the lower triangle should be in the middle of the upper one, but it can be connected to it anywhere in the base. So there are three different possibilities of connecting the lower triangle to the upper one to its base, as the base size of the upper triangle is 3. Now how do we solve it? So like any traditional dynamic programming problem, you first need a state to represent the problem characteristics. So in this particular case, we have tree as our focus, in which we need to find the maximum number of hashes in a given tree of height k. So in the input itself, you are given the grid in which that tree can be represented. Apart from that, you are given k itself. K means the total number of triangles that can be present in a tree. Now with those number of triangles, you need to find the max number of hashes characters that can be present in that tree. Okay, so now that tree, let's try to define a state which represents a tree. So there are multiple choices for that. One of the choices can be, we can define the lowermost base triangle for that tree. Then we can just put more triangles on top of it, or we can do it in the reverse way. We can define the topmost point of the tree and the number of triangles that are present in that tree. So the number of triangles is basically the height of the tree. So if we define in this way, we can say that f of x, y, k, where xy is the topmost point of the tree, xy is basically the cell number in the grid from where that particular tree starts. So if that xy is the topmost starting point and k is the total number of triangles that are present in that tree, then fxyk represents the max number of hash characters in that tree. And this is exactly what we want to compute. Let's say we computed fxyk for every xyk in this grid. Then we just need to output the max of all the possible values. Okay, let's try to break this into smaller subsets. What can we do? The first thing that comes to our mind is we can just fix the topmost triangle of some height. We can say that the topmost triangle is of height h. Then after that we can recursively solve the subproblems because if we fix the topmost triangle, the below tree will also follow the same properties of the bigger tree. So if we remove the topmost triangle, then it is still a tree, but the height will be reduced to k minus 1 because there are k minus 1 triangles now. So if we have topmost triangle of height h, and we computed the maximum value of h as like the size of the grid, we will start iterating from 1 to the max size of the grid for h. Now let's say we fix that height. But we can, let's say we know that maximum height, we pre-computed that height somehow. Currently I'm leaving that to you guys, you can try that later. Yeah, let's move on to the next one. So the key things to observe in a triangle are, let's say if the height of the triangle is h, then what is the size of the base? It's increasing by 2 after every level. So the level 1 triangle, the size of the base is 1. For level 2 it's 3, as you can see from the previous figures, but the size of the triangle of height h will be 2h minus 1. Now what will be the total number of cells in that particular triangle? So that will be equal to the summation of 1 plus 3 till 2h minus 1. So that is equal to h square. So we'll use this property. Now we want to compute f, x, y, k. And we just said that we are fixing the topmost triangle and its height is h. Now what? Let's say we remove this triangle and then we are just solving the subparts for the trees that are attached to this particular triangle. So where are those will be attached? So those trees will start from row number x plus h, and their y coordinate will vary from the coordinates of the base of the topmost triangle. So it will start from y minus h plus 1, and the height of those trees will be k minus 1 because we already removed one triangle from the initial bigger tree. So we will check for the answers for all those trees and take the maximum of those and add the h square value, which is the total number of hash characters in a topmost triangle. So that will give us the solution. I know it might be a little tricky, you can revisit it later, but yeah, this is the way. So this particular slide is missing one h square term that will be added to this expression, because h square is the number of total hash characters in the topmost triangle that we just removed from the bigger. Now now we will try to analyze the time complexity of this solution. But as we explained in CodeLab as well, the time complexity of a dynamic programming solution can be computed as the total number of states multiplied by the total cost for computing a single state. Now in this particular case, if you ask what is the total number of states present in this particular thing, it will be the total size of the grid multiplied by the total number of triangles possible. So everything is given in the input. So the total states are number of rows multiplied number of columns multiplied number of triangles. Now we need to compute the cost associated to calculate each state. So that will be, we will iterate on the height of the topmost triangle. We will iterate over its base to compute the maximum of the values that are present in the trees beside it. So that will give the cost, the total cost to compute that will be n cross m for a single state. This is the worst case, but it will be equivalent to this. So if we multiply these both terms, then we will get the final complexity, that is equal to m square times k. So if you look at the constraints present in this particular problem, so n, m and k all can go up to 100. So if you multiply these, then it will be roughly around 10 power 10. Our supercomputers, our daily usage computers are generally fast enough to compute around 10 over 9 iterations per second, or maybe a little more than that. So if you see, it will not take much time, but there are 100 test cases as well. So that will be roughly around 100 seconds or maybe 150 seconds to compute if there are all worst cases in that particular test file. So that is okay, but may not be fast enough if you are using a slow computer, or if your code is not well optimized and there are lots of constant factors involved in that. So to do that, we have one optimization that we can do in this particular case. So if you go back to that previous expression, we are computing a maximum of certain expressions. So if you observe that all expressions are part of a single array and can be seen as a subarray of that particular array. So there will be total number of rows multiplied by the total number of triangles that can be present in a tree, that many number of arrays, and in every array we need a maximum of some subarray. So that you can easily pre-compute. So you can also try this problem later. So this pre-computation can also be done in n square m square. So if you do that pre-computation, then the maximum, that expression that we have for maximum, can be computed in O of 1. So O is the notation to denote the time complexities. So if you use that fact, then the time complexity can be reduced to n square times k, which is definitely fast enough, and your code will surely work in under 5 seconds for sure. I hope I'm able to explain it, but if you're not, then the main motto to explain this tricky problem is to show you how to build up a solution step by step. There might be different things for different problems, but the traditional dynamic programming goes in this flow only. So most of the problems will be tackled in this way.
Okay, thanks a lot, Akash. Before moving on, let's take another question. So Amol says, a small query regarding language used for competitive coding. It occurred to me that scanning input using Java is slow. Should C++ be preferred over other languages for competitive coding? Lalit, you want to take that?
Yeah, sure. So in Java, I've seen that buffered reader is usually faster than scanning input. And also, all the problem setters usually make sure that we have at least solution in C++ and Java, because these are the most famous languages used by the computers. Also, on various platforms, there's a multiplier that is given to Java. So usually Java has a time limit which is 3x than C++. So I would say like C++ and Java are quite equivalent in terms of efficiency, if you want to say that.
So for CodeJam Kickstart, there is an additional constraint that you have to download the input file. Now, if the input file was really large, then downloading would also take time. So we consider that, and usually the input files are not large enough. So there is no problem with inputting them in Java or C++ or rather anything else, because they are usually small. Okay, moving on.
So as we had said earlier, we would talk about some of the nuances of programming in such a time-based environment. And so for example, in a kickstart round, you just have 2 hours and you have to come up with an algorithm and then write a bug-free solution, run it on the input files. So it's very possible that you are going to make a mistake, and it happens a lot of time. So what I want to talk about is how can we avoid making these mistakes. So one of the major mistakes that newbies make is the integer overflow, which is basically a sign of not considering all the corner cases. So for example, you are writing a code which consists of 100 lines, and there's a possibility that you can make a bug in a line, and there are hundreds of possibilities. So every line of code that you write in a programming contest, you should be exploring and thinking at all the times that what are the corner cases, what are the different values this variable can take, do I need to be aware about the integer overflow, am I missing some invariancy in my for loop, and so on. Also, there are some other things like you need to optimize your editor and coding speed based on you can define various macros. And for example, also like what I usually do is I define a C++ template in which I can trace variables very easily, which helps me to debug, to do printf debugging very quickly. Also, over the time, you can make a library of your own algorithms that you can reuse in the programming context. And also, there are some other slight improvements you can make in your coding speed with the help of autocomplete, auto indentation, basically editor features. But it depends on person to person. I won't say that it makes a huge difference, but if it works well with you, that's great. Also, there are efficient ways to code basically. So, for example, you can use references in C++ instead of referring to a variable again and again. You can define a reference with a smaller character. Now, as you can see on the left side, there are some macros that have been defined. But eventually, one thing that like many people ask is, do I need to care about the quality of the code that I write in online contests like Kickstart? And I would say that that's not necessary at all. We are not looking at your code. It's a cold-hearted machine which is judging your code. So you should not worry too much about the code quality. You need not comment what you're doing. So we will have a look at those skills in interviews. So.
Okay, great. Thanks a lot, Lalit. So we still have some time. If there are any questions, you can still ask in the chat and we'll take them. So there is one question by Hemant Kumar. In which way the upcoming contest is different from the last one? I would like to say it is not different in terms of the skills required or the theme specifically. Of course, the problems are different, but the contest in general would follow a similar pattern, a similar theme as the previous 6 contests. Remember, the next contest is on 22nd October. Are there any more questions?
And I guess this is going to be the last contest for this year.
That's right.
Yeah.
So this is going to be the last contest for 2017. So if you have not already participated, even if you have, go ahead, participate, have fun, enjoy. I mean, it's good to be on the top. Even if it's not, it would be a good learning experience. So I guess so we are done with questions.
So Akash, I would like to know, are there some very memorable contests for you?
Well, there are a lot. The recent Top Coder one was probably one of the memorable ones for me because I achieved the red rating in that. So that was on my target when I started doing the programming around 5-6 years back. So I was always excited to achieve this landmark, and finally I'm able to do this.
Okay,
fantastic. So there's one more question by Prashant. So I solved the problem previously and uploaded a working code. I believe you're talking about the second problem that we discussed, which satisfied the example dataset and small dataset as well. But after uploading the correct solution, it directly showed incorrect. So then, I mean, it's probably because there is some edge case which you might have missed. One of the things that we just talked about was, did you consider a possibility of an integer overflow? Because usually what happens in a large data set, the constraints are quite high. So there may be input of 10 raised to 4. Are you sure you did not do an integer overflow? If not, you should take a look again at your code and see if there are similar bugs like these. The edge cases in the large input set can be quite tricky, and it may fail only on the large data set but not on the small. But if you take a good look at your code, you probably would be able to find it.
So, and also I would like to mention that there is a very famous trick, you can call it trick, but let's say you know that your algorithm is correct, but there is some weird bug in some corner case that you're not covering, and your solution is working on small, as you said. So one of the things that I've employed in the past is that I write a brute force solution, which basically I'm pretty sure that I'm not going to create a bug in a brute force solution. And then I randomly generate some input, and then I match the output between my solution and the brute force solution. The reason this works is the brute force solution will only work on the small input, and to debug my solution, I need the small input as well, because if it's too huge, I won't know what's happening. So you can employ this method if it works.
That's a good answer. There's one more question by Piyush. What are the best resources for learning? Akash, you want to take that?
Yeah, so the best way to start doing any competitive programming or anything related to interviews or preparing for something similar. So once you should have one particular goal, you should know what you want to learn. So that way your half problem is solved. If you don't know what to learn, then discuss or consult with few the experienced ones who are already doing it from years. Once you know what to learn, then you can search for the material related to that. There is no one source for everything. So there are multiple things which are really good. We have multiple communities over multiple online judges which are fairly active and can point you to the good editorial or good resource for any particular topic. So first thing important is to what you want to learn. Let's say we want to learn MaxFlow now. So you should search for its materials. If you don't find any which are understandable to you, so it varies from person to person also. Some editorials and resources are simpler for one but not for the other. Then you can ask others on various forums about the material that can be more useful for that particular stuff. So yeah, that's the way to go.
Yeah, essentially, if you see there are basically two approaches. One is like breadth-first search. So you go to the Kickstart website, start solving previous problems, and then you look into the analysis that there is some concept that you don't know. So you go learn that concept and then come back and start solving problems again. This is the BFS approach. Another DFS approach is, let's say you encounter a topic which you don't know about. What you can do is learn about that, solve the problem that you're trying to solve, and at the same time deep dive into some other nuances of that algorithm. So let's say you don't know about MaxFlow and you encounter a problem. You can search for other problems related to MaxFlow and then solve 5 or 10 of them. So that would really make a concrete. You would have a concrete understanding of MaxFlow after that.
Great. Frankly, for me, I have referred to a lot of material on Topcoder. There are other sites as well, but just to lead you into give you a starting point, you can take a look at the material available on the Topcoder forums. Next question: what about Python? Is it good in terms of complexity? Mehmet?
For Kickstart, I think our input sizes are small and we have a very relaxed time limit. You get 4 minutes to generate your solution, your output file. So for Kickstart and CodeJam, I think Python works as well as Java or C++. You would not believe we have seen solutions in Excel in CodeJam. That was way too interesting. So yeah, Python works well.
Great. Sukruti asks, I wanted to know in what scenarios do you suggest using STL? Any tips, Akash?
Well, you should use STL always. That saves a lot of time for you, even in terms of coding plus understanding the concepts of a bigger problem. So if you tackle a bigger problem that is involving good data structures and lots of different computations, then using STL makes it a lot easier, not just in terms of code, but even in your own understanding, because you know that this particular problem is directly solved by some STL. The use of STL is kind of must almost always. Even if you are writing code in C now, but you want to learn STL and want to switch to C++, I would recommend start writing in C++ even without STL. So slowly and surely you will try to develop a habit that you can understand other C++ code well. So once you do that, you will see that people are doing that same stuff that you are doing this stuff in like 100 lines of code, but other people may be doing it in like 30-40 lines of code using STL. Then you will be fascinated to learn that, and that way you can improve in using STL.
Yes, certainly. So another thing is like you can look at other people's code. So once you have written your code, you can take a look at some elegant solutions which are much smaller in size than you. What additional things that they do? More often than not, they would have used some elegant STL solution, which would help you learn that even faster. Does Hemant asks, does wrong attempts affect rank? So the scoring on Kickstart is first decided by the score. It's not decided by the number of attempts you made to get to the right solution. But if there is a tie on the score, then the wrong attempts add a penalty of time, which is used for breaking the ties. So it does affect your rank, certainly, but first the goal is to get the right solution because that will increase your points. Then worry about wrong solutions affecting your rank. Okay, so I guess that is it from the questions part. We are also done with this talk. Thanks a lot for attending. It was really nice talking to you guys. Have fun and best of luck for the upcoming contest. Thank you.
All right.
Bye-bye.